Dear students, in today's class, we are going to see lab 2 of AML. That is how you are going to develop a artificial neural network model in which back propagation is already given. Means using TensorFlow, we can develop a neural network model in which back propagation is already inbuilt. Already you have learned in theory what do you mean by back propagation, in which we have forward pass and backward pass. Now, what is the forward pass? We are moving from input layer to the output layer, and in between hidden layers are there, and every node is having input, and every connected link is weighted. So that input should be multiplied with the weight, and we will add all these products, and which will give me a scalar product by summing together, and to it, I will add the bias and on which I will apply the activation function. So like this, we are proceeding from input layer to the output layer. Now at the output layer, we have got a output of first iteration, but that output, that is the predicted output, that will be compared with the target output, and difference between these two will be called as the error. Now, what is the main motive behind our neural network is while we are training a neural network, this error should be minimum. Okay, so that's why we are moving in backward direction, that is from the output layer to input layer by updating weights. So this all processing, that weight updation etc., from the output layer to hidden layer to input layer is done internally when you are using already built a model. Okay, now in lab 3 we will see how we can do the manual calculation and can perform the forward pass and backward pass, so that back propagation will be performed. Okay. Now, while developing a neural network model, the packages that I will use is, as I told you, the two basic packages that I need is NumPy and Pandas. Okay. Then for plotting my graphs, I need Seaborn, and for plotting my accuracy and loss, I need Matplotlib. Okay. Then to divide my data in training and testing, I need Scaleno package, and even to see the classification reporting confusion matrix also, I lean scalar matrix. Then TensorFlow, I need to develop the neural network. Now, as I told you in last lab, to read your data set, you will use read CSV method. And here you can use two backward slashes or one forward slash by specifying the path as an argument to your read CSV. So name of my data set is a data, and which I'm loading in a data frame. The variable is the DL. Okay. So here, this is a cancer data set, and here all you can see as numerical values only, except one, that is the diagnosis, that is having the data type as a object. So what I have observed is when students are practicing experiments, they are simply copying and pasting. Okay, so the commands they are not able to execute during lab internal exam. So whatever are the necessary commands to develop your model, just remember those commands. Now the first command was importing package, that is required. The second one, reading dataset, that is required. The next one is this ID column I don't want, so I'm dropping that one. Okay, either you can drop it or you can keep it as it is, means it is not affecting my model anyhow. Okay, now the info command, just to see what are the columns available. Though you don't remember this command, it's okay. You can develop a neural network model. So what I am telling you is that just learn the necessity commands to develop your neural network model. Okay. Now, important thing, you know that only diagnosis is the column which is of object data type. So I am converting it to the numerical values by a if-else condition. Means if it is having only two values, that is M and B. So when it is M, I will give it as a 1, and when it is B, I will give it as a 0. So, and this column I will take as my target column, that is the Y. Okay, that is a dependent column. So means that is a telling me what type of the cancer is diagnosed in a patient. Okay, so as it is having only two values, this is the example of the binary classification. Okay, so this is important command. So till now, three important commands: importing package, reading your data set, and converting your diagnosis object value to the numerical value. Okay. Then after that, you can check whether it is converted or not. Now it is converted to an integer type. Then I'm describing some statistics. This is also not a necessary command to me. Now, the most important command. In Y, what I want to store? Diagnosis. Okay. And in X, I want to store all the columns except diagnosis. Now, diagnosis is at index 1 in the columns. So, except it, I want to store all 1. That's why in ilocate command, you should give 1 value here. Okay. Then this command is not required, that subtracting from X, its minimum and maximum not required. So just specify what you need in X and Y, what you need as dependent and independent. Now, the next very important step that you should divide your data set in the training and testing sets. Okay, so apply the train test split method from your sklearn, and here I am taking the test size as 0.2, means what? 80% data I will take to training and 20% I will give to testing. Okay. Then after that, I will check how many rows I got in training and testing. Now, these are the next four important cells which you will use to develop your model. So the first command, you are telling that I want a sequential model. Sequential model means what? It will build the model using the stacked layers. Okay, so layers will be arranged in a stack. Now, the first layer will be your input layer. Now, after that, I want the first hidden layer. ANN model, we are using input layer, hidden layer, and output layer. So these layers I want to arrange like a stack, one after another. So I'm using here the word sequential. Okay. Now, after your input layer, you are using the first hidden layer. Okay. So the number of neurons in the first hidden layer, I want 6. So that you should specify using units variable, that is units is equal to 6. And here the activation function that I'm using is ReLU, that is a rectified linear unit. Okay, I generally do remember that in hidden layers, we use the activation function as ReLU, and in output layer, we use the activation function as sigmoid when you are going for the binary classification. Now, I want to add the second hidden layer in my ANN model. So again, I will use the same syntax, means just copy paste. Okay. Now the output layer, I want only one unit because it is a binary classification. So the output will be only one. And only the change that you have to do is activation function you should change from the ReLU to sigmoid. Now remember, in this model, 661 combination I have got. Now, during your lab exams, I will give you the question as what combination I am expecting for your model development. It may be 6, 12, 24, 48, then like that. So, those many layers you should add using this syntax. Okay. So, just learn adding number of neurons in one layer, what syntax we need. Just you have to learn it. Okay. Now, the next one, I will compile my model with the optimizer as Adam. The loss that I'm using is a binary cross entropy, and the evaluation metrics will be the accuracy. Now, I should apply this model, means I should train this model, hence I'm using the fit method. So on my training data, that is a X and Y, the number of batches that I'm using is 32, the number of epoch is 100. Now, number of batches is equal to 32 means what? In 32 batches, my data will be divided. Epoch is equal to 100 means what? 100 iterations will be performed in my model. Okay. Now, verbose is equal to 1 means what? After each epoch, what is your accuracy and loss should be displayed to me as it is displayed in the output. Hence, you are keeping the verbose is equal to 1. And what is your validation data? That is your testing partition. Okay. Now, after this, what you will do? You will predict. Means you will test how well my model is trained. So apply the predict method on X test partition and you will get the Y predictor. So this is the predicted output. Now here you can see that the first one is a predicted value. The second one is the target value. If both are same, no error. So let's see from top to bottom, is there any mismatch? Can you get anything? Yes, it is there. So this is giving me the difference between the predicted and target value. That is what your loss. You want to avoid this loss. That's why you are performing the back propagation. That's why you are updating your weights in the backward direction. Okay. That is from the output layer to the hidden to the input layer. Now, whatever is your output, that output should be visualized using plots. So take from your history the uh, training accuracy and loss, validation accuracy and loss. Okay. And plot it for every epoch. Okay. By using the G and B, means G stands for green color and B stands for the blue color. Okay. And what label you want to give, specify it. And same thing you will do for the loss. Okay. Now here you can see the plots that are obtained. Now, what will be the assignment task to you is just change the number of the combinations that you are using. Instead of simply 661, try some other combination, that is 6 12 1, 6 12 12 1, 6 12 24 1, like that, and see what change you see in the output. Okay. And remember only the necessity cells that are required to implement your model. Don't learn extra cells. Means you know it. Info, describe, reshape, these all you know. But these are not required for my model development. Only remember the cells that I need for my model development. Okay. So that's all for your lab 2, that is developing a ANN model by applying the backpropagation internally. Okay. Thank you.